It said evil eyebrow. That was for AP stat. All right. So let's chat about it. I'm gonna put answers up on the board. All right. So, oh, this is good. All right. So answers up here on the board. Let's talk about it. So you're buying a Kia Soul. Okay. And down payment. That does take away from the total amount, but in this problem, we are not including the down payment. So make sure that you always read the problem because I know we made that mistake. So our monthly car payment would be $639. Our yearly, so we would multiply that by 12 to get the yearly. So we would multiply by 12 to get the yearly. Okay. And then we would take that and we would multiply it by 3 to get the over 3 years. Everybody see how we do those columns? Okay. Now maintenance, they told us that maintenance would be $540 per year. So in order to get the monthly, we would divide by 12. Gas, they tell us that it's $100 per month. So we would put 100 here. We would multiply by 12 here and then multiply by 3 to get that there. Insurance, that's going to be $1,200 every 6 months. So if I wanted to do the monthly, I would divide by 6 to get the monthly. And then yearly, I would multiply by 12. And then I would multiply by 3 to get over here. Okay. So for 3 years to pay for this car, it would cost you $35,424. That's to drive a car. Questions on this? For the car payment, we took this and then we used our formula for the monthly payment. That's up at the top right here. Do you remember monthly payment from unit 2? So you would use that formula. Yep. So if you were not here on Friday, we use the monthly payment in order to get the car payment. Okay. All right. Go ahead and fill out the table down at the bottom. Now that you've seen one, try the next one. Okay, so now that you've seen one. All right, so there's the second problem. Okay, the way you got your monthly, remember, is your monthly payment formula. Okay, again, don't include your down payment on this one. Maintenance on the car is about $740 each year. Okay, so you would put that in the yearly, divide it by 12 to get the monthly, and then $100 per month for gas, $1,200 for yearly, and then for insurance, it would be $1,080 every 6 months. So you would divide by 6, and that would give you $180. For yearly, you would multiply it by 12. And then you would take this entire column, multiply it by 3 to get this column. And your total would be $30,000. Which car do you think he should buy? Both of them are Kia Souls. Thought you said you did this one already. I did. It was that wrong? I did. Lord. Okay. Questions about this one? Yes, ma'am. Yes. It should be on the stream. Go all the way down to the bottom. Like, go to your stream, not classes. Classwork stream. Go all the way down to the bottom. Keep going. Okay, so there should be something called YouTube links. Click that. Click that document. And then there's links. Yes, but no, they haven't done an all call. Okay, we're gonna come back to that last one in just a second. So let's go ahead and do our notes for today. We're talking about automobile depreciation. So go ahead and find that. All right, so I can model the value of automobiles as they depreciate over time. I can use the depreciation formula to calculate the value of items. So when you buy a car, does it increase in value or decrease in value? Decrease. Why? So, what about those old-timey cars? Aren't they worth something? Okay. Okay. All right. So, assets such as automobiles lose value over time due to normal use. Okay, so depreciation is that the value goes down. So lose value over time. Depreciation is the monetary loss of value as a result of wear and tear. Okay, so just like what he was saying, it's going to depreciate, it's going to go down because you're using it. Now, identify each graph below and select the graph that best fits the way in which the value of the most cars depreciate over time. So really quick, if you did not know, okay, looking at this class, this right here is a linear function. This right here is a exponential. And this is decay. This is linear. This is exponential growth. Okay, so A, B, C, or D, which one do you think displays depreciation for an age of a car? B, why? Yep, okay. Okay. So when you buy a Tesla and you drive it off the lot, it already drops 50% of its value because somebody has driven it. Okay. So based on what factors you know about car in the list, what do you think affects depreciation factors? So just like what you said, wear and tear, and also reputation of the manufacturer. What type of car retains its value? Not a Tesla. Not a Tesla. No, no. I'm talking like brand, like say again. Oh my God. Okay, Toyota. Toyota. Okay. So Toyota or Nissan. Nissans hold their value really well. Yes. Ford doesn't hold its value really well. Tesla does not hold its value very well. No. Nah. So Toyotas have like a warranty where you can hit like your 200,000 mile warranty. Like they will go forever. Yeah. Say again. Chevys don't hold their value very well. They kind of fluctuate depending on the type of car. Oh, you're talking about the spider bikes or whatever they are? No, absolutely not. Yeah. No. Nope. All right. So really quick. So we've got right here the top 5 highest vehicle depreciation rate. So the Nissan Leaf has an average 5-year depreciation rate of 65.1%. Not so great. The top 5 lowest vehicle depreciation rates. Okay, so ready? A Jeep Wrangler, the Porsche 911, and the Toyota Tacoma and the Toyota Tundra. Okay, these don't lose their values a lot. They're normally about the same. Okay. Boyfriend has a Tundra. That thing will run forever. That thing will go forever on it. Okay. So that's why they don't lose their value a whole lot. Just because the manufacturer that they have. All right, go ahead and flip the page. We're going to complete the table to determine the value of a $16,000 car after 4 years of 25% depreciation. Okay. So really quick, we've got a $16,000 car. We're going to multiply by the depreciation rate. They told us 25%, right? So if we just take 16,000 and multiply by 0.25, we get 12,000. If we take 12,000 and multiply it by 0.25, how much do we get? I need you to use your calculator. 12,000 times 0.25. $12,000 times 0.25. Oh, I'm sorry. So 12,000 times 0.25 would give us 3,000. Okay, so that's how much we're losing each time, right? So what's 12,000 minus 3,000? 9,000. Okay, so now we're going to do 9,000 times 0.25. What does that give me? Yep. Okay, hey, can y'all grab that door? Okay, and then we're going to subtract that. We're going to subtract that from 9,000, and that's going to give us 6,750. And then we're going to take 6,750 and multiply it by 0.25. Okay. And that's going to give us 1,687.5. We're going to subtract that from 750, 6,750. And that's going to give us 5,062.5. Okay, so the formula we just used on this was this guy. You're going to recognize it. Dude, you're doing way too much, yo. Way too much. Okay. All right, so automobiles. Okay, so automobiles depreciate in a non-linear way. Okay, an exponential function. Guys. Okay, automobile depreciation can occur in a non-linear way. So this is going to be an exponential way. Okay. An exponential function is used. Exponential function is used when there's a constant percent change. Okay. So here are some reminders. Here are your formulas. We've got growth and we got decay. Remember, depreciation is going to be decay. So A is going to be my initial amount. Initial amount. R is going to be my rate. And X is going to be the number of growth periods. Okay. So again, we've seen this formula before. You've actually talked about it in Algebra 1. Here it is again. Okay. So in example 1, it says the Porsche 911 GT3 costs $182,900. From the list above, we see that the 911 depreciates at 12.8% over 5 years. Okay, so we're going to find the depreciation, right? The annual depreciation is 12.8%, okay, over 5 years. So 12.8% divided by 5 years tells me that it depreciates at 2.56% per year. Okay, so look at it one more time. Hey, what's up? No, he's not. Thanks. Okay, If that's the case, then what was our principal amount? 182,900. We're going to do 1 minus 0.0256. And we want to find the value of the car after how many years? Is it 5 years? How much do they want us to find it after? 8 years. Okay. So we're going to plug in 8 for our t. And tell me what you get. You plug this into your calculator, you're going to get 148,631.86. Okay, what I want you to try is go ahead and flip to example 2. I want you to do these 2 steps. Find the annual percentage rate, that's what we did up here, and then find the value after 8 years. That's what we did down here. Okay, so go ahead and take a moment, try example 2. Just so we know what types of cars we're talking about, this is a Porsche 911 GT3. Okay. A little thin, yes. Okay, here's the Nissan Leaf. Now, hey, the Nissan Leaf is all electric. Okay. So just in case you didn't know. So we're going to calculate it. This is the depreciation rate. Okay, so 65.1% over 5 years. So we're going to find it for the annual depreciation rate. So 65.1 divided by 5. What does that give me? 13.02%, right? Okay, now we're going to use the formula above to calculate the value after 8 years. So we got A times 1 minus R raised to the X, right? So our initial is 28,140 times 1 minus 0.1302, and we're going to plug in 8 for the exponent. When you do that, it's going to drop to 9,218.90. So we went from a $28,000 car to a $9,000 car in 8 years. Okay. All right. Example 3, car A costs $25,000 and has an annual depreciation rate of 15%. Car B costs $23,000 but depreciates at only 12% per year. Complete the table and graph the values on the same graph. Okay. You're going to probably need different colored pencils, or you can do pen and pencil. It doesn't matter to me. So on the first year, car A was $25,000, right? Okay, we're going to fill in this table. So each year we're losing 15%. That means that we're going to do 25,000 times 1 minus 0.15 raised to the whatever year it is. Fun fact, Desmos does this for you. So when you go in here, you can type in the formula. Remember, instead of a T, you're going to put X. If you hit this little gear button and hit the table, it'll pull up the table, and then you can enter more years to figure out how much it is. Does everybody see it? Okay, so here's my table right here. So go ahead and copy that down. You're going to round to 2 decimal places. You're going to round to 2 decimal places. So you're going to start at 0, put the 25,000 in, and then keep writing these in. Okay, so take a moment, fill that out. So when we plot these, go back to this page. Okay, when we plot these, what you want to do is, here are your years. So down here at the bottom, this is the years of depreciation, and then this is the value of the car in money, obviously. Okay, so at year 0, we're at 25,000. At year 1, we're at 21,250. At year 2, we're at 18,000. Year 3, we're at 15. 4, we're at 13. 11. 9. 8. 6. Okay, and so on and so forth. Okay, can you take a moment? Can you plug in the next one? Okay, so for car B, you're starting with 23,000 and you're depreciating at 12%. Go ahead and plug that in. Okay, so you should have gotten this table. Okay, and when you plot this, it's going to be very similar to what we had happen on A. Okay, again, I would suggest plotting these in different colors if you can do that. So for B, we got 23,000 and then 20,000 and then 17,000. There's going to be a little bit of an overlap. 15,000 and then 13,000, 11,000, 10,000, 9,000, and then 7,000. And we're connect. Boom. Okay. And again, you want to probably label them just in case. So which car is a better value after 8 years? Which is worth more after 8 years? B. Okay. B costs less though. Okay. Something to keep in mind. All right, let's take a look at the next part. Okay. What does the IRS stand for? Yes. Internal Revenue Service. Allows businesses to reduce the amount of income tax they owe by reporting depreciation of certain assets. Some examples of this are automobiles, equipment, buildings, etc. Okay, but you can actually get a tax deduction based off of the automobiles, the equipment, and the buildings that you purchase for your business. Okay, which is kind of nice. So depreciation is often calculated for accounting and tax purposes. You're going to use a linear model. Using a linear model. I'll scroll up so you can see it. Linear model. And this is often referred to as straight line depreciation. Okay, so example 4, if a business purchases a $60,000 work van and believes it will depreciate to a $0 value in 12 years, how much value will the business report as straight line depreciation on the van each year? Okay, so if it costs $60,000 and they're going to say that in 12 years it's going to be worth $0, right? Then each year it would cost us $5,000. They're going to claim this report for $5,000 each year. All right, so we're going to complete the table showing the straight line depreciated value of $60,000 work van, okay, as it depreciates by $5,000 per year. So what you're going to do is you're going to start off with 60,000 and subtract 5,000 each year. Okay. So coming down here, You're going to start at 60,000. And subtract 5,000 each year and drop it down. Okay. So go ahead and take a moment. Go ahead and fill in this table. Okay. So now that we filled in that table, and all we did was subtract as we were going. Okay. Now we're going to draw the linear function. So you're just going to plot these points. Okay. I'm going to just do it by tens. I'm just kind of skipping through. Boom. Okay. You should get a straight line and it should be going down. If it's not, then you got something wrong. Okay. What is the slope of this function? What do we go down by each time? 5, right? 5,000. We're going from, and if we do it just based off of this, we went down 10 over 2. Down 10 over 2. So down 10 over 2. That's negative 5,000, right? What's the y-intercept? It's what our initial amount was, which was 60,000. So if we were to write the equation for this, we would say y equals negative 5,000 x plus 60,000. On your quiz tomorrow, it's going to ask you for this equation. Okay. Questions on that? Fairly simple. It's almost like a repeat of unit 2. Kind of. Okay. All right, let's take a look at the next page. Systems of equations. Here's the new part. Okay. What is a system of equations? Anybody know? Say it again. Am I just talking to myself today? Yep. Okay, so 2 equations or more that describe a relationship. Okay. The graph at the right shows the data of a car's exponential and linear depreciation values over time. What was the original value of the car? So where does it cross the y-intercept? Look at that graph. Where does it cross the y-intercept? What's halfway between 45,000 and 50,000? 47,000. Okay. The linear depreciation value of the car is shown over how many years? So how long did that line, that straight line, go for? 12 years. Okay, it went for 12 years. In how many years will the linear and exponential values be equal? Where do they cross over? 10.5-ish years. Okay. What is true about the domain from 0 to 10.5? Okay. So looking from here to here, what can we say about the domain for these? It's decreasing. Compare the exponential versus the linear. Is this one dropping at a faster rate or slower rate? Faster rate. So the linear drops at a slower rate than the exponential. Everybody okay on that one? Nothing crazy. Okay. All right. Example, you are planning to purchase a new car with an auto loan. Okay. The graph at the right, it represents the system of equations for the value of the car and the amount paid. Use the graph to answer the question. What was the initial value of the car? What was the initial value of the car? What's the y-intercept? 50,000. What was the down payment?
157.
Mm-hmm. What's the down payment? How much was the car totally worth? Can you tell? They got a lot going on in this graph. Look up at the top right. How much was it totally? 62,946.80. And then you told me that the initial value of the car is 50,000, right? What's the difference between those two? Oh, I'm sorry. What was the initial value of the car? Hmm. Okay. So how much is that going to be? How much did they pay for the car? The total paid for the car is including like taxes, fees, etc. So the initial value is 50,000. We're trying to figure out what the down payment was. I'm not understanding where they get 54,000 from. That's okay. All right. About what time will you have paid the same amount that the car is worth? Is it 10 years? How much is the car worth? No, let's look at this again. Okay, so if your monthly payment was $457.89, okay, and how much is the car? The car is, okay, so what point is that? About 3.5, yeah, roughly. That is when it's equal. Is when it's equal. So about 3.5 years, you will have paid the same amount that the car is worth. So like right here, that's when you paid the same amount as what the car is worth. So why does the slope change at this very end? Why does the slope change? Because you finish paying, right? It's no longer increasing. Okay, so looking at this, why did the slope change? Because you paid off the car. What is the difference between the value of the car and the total amount paid for the car at the end of the loan? So you told me that the total amount was 62,946, $0.80. And we're going to subtract how much that car is worth, which is $7,758.02. And that's going to give me 55,188.72. All right, 18. If you paid $2,000 down and the lease this car for $457.89 per month for 3 years, and are given the option to buy, what should be your offer based on the graph? So how much should you pay for a car? So I don't know if you know this. You can actually lease a car, you can rent out a car, and then after a certain number of years, you can actually just buy that car. A lot of people do it. Sometimes it's a cheaper way, sometimes it's not, depending on what type of car you got. Okay. My buddy did that a couple years back. Okay. So how do we figure this out? Well, the amount paid was you did a $2,000 down payment, plus you made $457.89 payment. How many months did you pay that for? 3 years. So how many months is that? 36. So you spent $18,484.04. The full value of the car is how much? How much is the car fully worth? 62,946.80. And so your offer should be 62,946.80 minus what you already paid for. So when we subtract that, I'm going to get 44,462.76. Okay, this is the most common question that they ask. A car costs $23,000 new and sells for $19,000 5 years later. What is the depreciation rate? So our initial is 23,000. We got 1 minus, we don't know what R is, and we're doing this for 5 years. Yep. And we're going to set that equal to 19,000. Here's how you do this. You go into Desmos. You type this in. We don't know what R is, so we're just going to name it X. Wherever it crosses the X-axis, that's where our solution is. If you can zoom in. I don't know why this is making me go all the way in to literally click on it. Anybody got that number? It should be 0.0375, right? Okay, cool. So R would equal 3.75%. What are some ways to reduce the depreciation factor? Does anybody know? What are some ways to reduce the depreciation factor? There's some ways to reduce the depreciation factor. Say it again. Buy an older car. Okay. Maybe purchase something more reliable. Keep mileage down. So, for instance, boyfriend bought a Toyota Tundra back in 2017. Great car, fabulous car. From 2017 to now, that's what, 7 years? Yeah, we're in 2024? No? Yes. Yeah, that's today. 2017. Yeah. Okay, so that's 7 years. He has 140,000 miles on it, right? He hasn't finished paying it off. So if he's wanting to buy a new car, he's got to finish paying it off, or somebody else has to take over that loan. Well, nobody else is going to take over that loan because it's got 140,000 miles on it. Yeah. So keep mileage down, find a reliable purchase or a reliable brand. What other ways can you reduce the depreciation factor? Okay, I want everybody to pause. Go ahead, go to Google. I want you to type in, what are some ways to reduce depreciation factor? Yes, Tyler, usage. What do you mean? You're just reading it? Okay. So, many a times, like older people will take their cars to get tuned up, right? So they'll have their tires rotated, the oil changed. You want to make sure that you're keeping your oil changed every like 5,000 to 10,000 miles. Okay. What else did you find out? Yeah, that's a good one. So, no crashes. Okay. What else? Yep. Tax incentives. What do you mean by that? Can you read more on that? Read it to me. Okay. So when you go and you do your registration and your taxes each year, maybe they have specific reliefs on certain cars. Okay. I don't get that privilege. That's okay. All right. Anything else? Okay. So really quick, tonight, your project is due. So if you have any last minute questions, I will take them until 10:20. If you email me later today asking me about the project, I'm not going to answer. That's not because I don't love you. It's because you waited too long. Okay. So if you want to look at your project right now, go ahead and do that.